Recursion slides. Off we go. So we learned the magic of recursion, right? We get to assume that the smaller call works, the recursive call works, gives us back our answer. It works its way down to the base case, build its answer back up using the recursive case. We watched it work, and then the last thing we tried was a program to generate the Fibonacci sequence. Okay, Fibonacci sequence. And let me just copy that code into today's lecture because we need to talk about it some more, right? We ended on an interesting dilemma, right? 21, I called it fib.cpp. Let's go here. So here was the program, right? The Fibonacci sequence works like this. You got two base cases and then a recursive case that makes two calls, right? Because every Fibonacci number 7 is the sum of Fibonacci number 6 plus 5, the 5 and 8. So it has to go off and compute those twice, all right? Two separate calls. And let's see, it works for smaller things. It works for fib of 7, but it would not work for fib of 100 within our lifetime or any of our descendants' lifetimes, all right? So that was an issue. And we have to talk about why is this going to take longer than the universe has existed to call fib of 100, all right? It's a great segue into CSCI 41 land. That you'll see this again in CSCI 41 for sure. But it'll never finish, so I got to stop it. What's wrong? Right? The issue is that we are repeating a lot of work because of those two separate recursive calls in that function. So we're calling fib of n minus 1, getting that answer, then calling fib of n minus 2, getting that answer, and then summing them together. That's secretly what's going on under the hood, right? So when I ask for fib of 5, C++ is going to go off and be like, oh, okay, I need to sum up the values of fib of 4 with fib of 3. I need both of those right now. Go and get them for me. So it needs to go off and compute each of them. And it's just working on fib of 4 for a while, and then it goes off and it calls fib of 3 after that. So to calculate fib of 4, what does it do? Again, it's going to be the recursive case, right? It's going to call fib of 3 and fib of 2 and sum their answer when it gets them both back. So fib of 4 is going to make itself two calls, right? Fib of 4 is going to call fib of 3, it's going to add that answer to fib of 2. And you can imagine what fib of 3 is going to do now. To get its answer, again, it's the recursive case, so it's got to call fib of 2 and fib of 1. Do you see the problem? Fib of 1 and sum those answers back once it gets them. Fib of 1 is finally a base case, but fib of 2 isn't, right? So we have to, how do you implement that? We got to run the recursive case again to sum up fib of 1 and fib of 0. Those are finally base cases, so you can stop there. And then okay, we got the answer for fib of 2 now, let's use it in fib of 3. And then fib of 4 gets the answer for fib of 3 and it just goes off and recomputes fib of 2. You see the problem? That's wasted work. We've already done it over here, but we just forgot about that. So we're going to do it again. So fib of 2 over here now is going to call fib of 1. It's a lot of wasted work. Fib of 1 and fib of 0. Those are base cases, so I can stop. And then, all right, we're done fib of 4. Let's do fib of 3. And you see that it's going to do all this all over again. All right, let me draw it out. Fib of 3 has got to call fib of 2 and sum that with fib of 1. And then fib of 2 has got to run out of room, got to call fib of 1 and sub it with fib of 0. And those are finally all base cases. Okay? Do you see the issue? Look at all the times we had to call fib of 2. It's a disgusting amount of times. All these guys. There's a fib of 2 call. There's a fib of 2 call. It doesn't remember. It has no memory of its last time it did that, right? There's fib of 2 everywhere. There's a bunch of those. And then you see that fib of 3 also it's been duplicated in here. All this work to compute fib of 3. It's a lot of calls deep down, right? There's fib of 3 happening a couple places. And then you can imagine that if this was a fib of 6 call, right? It would do fib of 5 plus fib of 4. So it's got to do all this over again over here. The second you do one higher up, you double the work, essentially. Does that make sense to us? That's disgusting. So there's a better way, but this is the naive way, and that's kind of cool that you can see what's going wrong. And you can imagine 1 second, you double 1 second, that's 2 seconds. Double 2 seconds, that's 4 seconds. It's you doubled it 100 times, and that's just a ridiculous number of years that humans can't even comprehend. Okay? So that's the problem. That's what's going on. Fib of n plus 1, you can imagine, is twice as hard about. It does lean a little bit to the left. It's fib of 4 and fib of 3, but it's essentially doubling the work every time you call fib of 6, fib of 7. Okay, so there is a way to fix this and remember your old uses of fib of 3 and it'll make it fast, but you'll have to wait until at least CSCI 41, if not a algorithms class at a 4-year college to fully break down and find a way to make it recursive still and like make it actually not be horrible. Okay, but at least now we know the problem. Any questions about that before I go to like normal stuff again? Cool, this is like an analysis. We did an analysis of an algorithm. That's a 41 kind of topic. All right, let's do some more recursion examples. Let's make a function that's just like a void function that is recursive though, that prints a bunch of numbers, prints from 1 to some number n in order. So like you pass along n. So the job of like, if you ask for, you call print from 1 to with the argument, let's say 5, print from 1 to with like 5. What should happen when you make that call? Well, here's what it should print, right? It should just print from 1 to 5 in the output screen. That's what we're about to do, and I claim that this is a recursive problem, and let's go and find it inside of itself. Question first? Okay, what about it? Oh, sure. Yes, there's a way to calculate that. You can imagine that it takes let's say, it takes 1 nanosecond for a computer to do something, like very small, like an addition. So pretend that every fib call is 1 nanosecond, okay? And then fib of 5 is essentially doing 2 to the 5 amount of work. 2 to the 5th power-ish. It's like 32-ish things. If you do that kind of, it's like a power kind of operation. So 2 to the 100 is doing that many-ish things. And if you convert, like pretend it's nanoseconds, that's a lower bound. Like convert that to seconds, and it's billions of billions of billions of years. Okay? Yeah. So that's the problem. That's why. Good question. Any other questions? So yeah, we want to do print from 1 to 2, and I claim that this is a recursive problem. Does anybody see a smaller print from 1 to something inside of this? Anybody point it out to me? You see it? Good, yeah, 1 to 4. You're always looking for the next smaller one, so that's good to notice that. But you see how there's a 1 to 4 printing problem in here, as well as a 1 to 3 and a 1 to 2. Like, there's this one, there's that one. It's 1 to something, right? It's always 1 to something. It breaks down like that. So there is your smaller call. That's your recursive call right there. Okay, so in the recursive case, here's what we're going to do. All right, we're printing from 1 to some number. Well, first print from 1 to 4. 1 to 1 smaller. Recursively print from 1 to n minus 1. That's your recursive call. And due to the magic of recursion, you just get to assume that when you call yourself, it's going to do the right thing. Assume this works. Spend no extra thought processes for that. Just assume that, all right, that's going to print 1 to 4 for me. How do I build up the final answer using that? That's all you have to be thinking. Because it will do it right if you do it correctly, if you build it up correctly. It's like, all right, this is going to print from 1 to 4. What do I still have left to do for my bigger original problem? I got to print the 5 because that's what the recursion didn't handle. All right? You can imagine that you get to pretend that it's going to do the thing on the smaller problem. You just got to build up the answer using that, and it really will work. All right? And then the final answer involves the base case too, right? You give the recursive case usually, but the base case stops you. It's like, when do you stop is now the question. So if you kind of break this down, like I want to print from 1 to 5, following the recursive case, I got to print from 1 to 4 first. That checks out. And then printing from 1 to 4, we'll print from 1 to 3 first. That works. We'll print from 1 to 2 first. That still makes sense. From 1 to 1, that could be a base case because you only have one number to print. Or just like make it easy on ourselves. Let's say that we want to print from 1 to 0, an even smaller problem, right? I want to print all the numbers from 1 to 0 in order, and that could be my base case. And it's an easy base case because there are no numbers between 1 and 0 ascending, are there? So just do nothing in the base case, and it'll work. Okay? So that's going to be the secret, and let's code that up, and I'll draw a picture. So I'll call this recursive printing.cpp. And yeah, let's do print from 1 to like 5, right? And so it's void, print from 1 to, and it takes some number n. And again, we're either in a base case or a recursive case, right? So if n is 0, that's our base case. So base case, I want to print from 1 to 0, right, in order. There are no numbers in that order, so let's just do nothing. There we go. Do nothing. And so I just have an empty body. Alternatively, you could just have like an if that checks for the recursive case only. Like that'll work too. But just let it return. Else, now this is the recursive case. All right. What do I want to do in the recursive case? Well, I need to like I need the 1 to 4 first and then my 5, right? So the smaller call happens first, all right? So I want to, in this order, recursively print from 1 to n minus 1, and then I need to, like, that'll be my smaller call, and then I need to build up the final answer by printing my own n, right? So how do I print from 1 to n minus 1? Well, that's a smaller call to me. I just get to assume that if I do this call right here, it's going to work. It'll print from 1 to 4. It'll do it. I don't have to think about it. As long as I build up the answer correctly, it will work. And the last piece of the puzzle is to print my own n to build up the final answer to the original problem, right? So let's compile this. And it will work. Again, no loops in sight, but bam, do I get 1 through 5. All right? So here I am calling it in main, and then here is the implementation that is giving me 1 to 5 printed out. All right? Any questions about this code before I draw a picture of why on the stack it's working? All right. So yeah, it's good to draw these stack diagrams as we're thinking about these things. So let's say, all right, I'll call it P to save me some drawing, and let's draw what's happening. Why is this working? All right, so it's main. Main kicks it off. Main calls print from 1 to 5, right? So main calls, I'll draw that as P of 5. Simpler for me, but remember that really means we got an n variable and it holds 5. Okay, that's what I mean by that. So, all right, P of 5. We're sitting up here, our n is 5, and all right, 5's not 0, so recursive case. So in order to print from 1 to 5, I first must call this, print from 1 to 4, make it complete, do all that work, and then I'll print my n right after that. So this original call to print from 1 to 5 is going to call print from 1 to 4 and wait on that. It's going to be stuck right here while it's working on P of 4. P of 5 calls P of 4. Does that make sense to us? Is it coming back? Yeah, so P of 5 calls P of 4, and I think you see how it's going to make its way down. All right, I want to print from 1 to 4 now. I'm working on that. N is 4. Well, it's not the base case, so I need to recursively print from 1 to 3, and then I'll print my 4. So I'm going to wait right here. All right, wait for P of 3 to complete. All right, so all these calls, except for the top one, are waiting on this line for the person above them. Print from 1 to the smaller thing. All right, it's making its way down to the base case. And then P of 3, again, recursive case, so it'll hit this line, print from 1 to 2 recursively before it can print its 3. So it's not done. P of 2, and then, again, recursive case. How do you print from 1 to 2? Well, you got to print from 1 to 1. Then you can print your 2. So everybody's going to be waiting on this line. P of 2 needs to go off and call P of 1. Bam. And then remember, this means like they all have their own n variable. Like the n for this call is 1, right? And so now we're in P of 1. Everybody else underneath is waiting. There's a bunch of different calls waiting on this line, right? And then P of 1, all right, it's almost done. Got to print from 1 to 0. It's going to make that call, and then print its 1. So P of 1 has to call P of 0. All right, and so now n is 0. And we've made it to the base case. So everybody else, though, they're waiting on this line for the person above. P of 5 is waiting on P of 4. P of 4 is waiting on P of 3. All of these calls have not yet finished. They're all looking ahead, looking at the person above them, waiting for that work to be done. Okay? So P of 0 is finally going to kick it off. We've made it down to the base case. N is 0. It'll do nothing in return. And like that's the right answer for that particular call. Here's like my output screen, for example. That does nothing, and that's what we wanted, actually. Now we're like it returns. It returns. We're back in P of 1 to print from 1 to 1. So we just printed from 1 to 0. That's done. Now it's our turn to print our 1. All right, so we're back up here. We print our 1. And now we're done. We return back to whoever called us, who was P of 2, who was waiting on this line to print from 1 to 1. We've just done that correctly. You see that? And now, all right, we waited so long. Now it's time to print our 2. That was the last piece of that puzzle. Now we're done. Return to who called us. Now we're back in P of 3, who's waiting ever so patiently for print from 1 to 2 to be finished. It's done that. It's finally given control back to P of 3. So, all right, it's my turn to print my 3. It's building up its answer correctly. And that is the correct answer to print from 1 to 3, isn't it? It is really working. It's building its way back up. Now it's going to return to whoever called it. All right, its job is done. Now we're back in what? P of 4, who's waiting to print from 1 to 3. Finished. Now it's time to print its 4. Now it's done. Return to who called it, which is the original call, finally. We're back in P of 5. It was waiting so patiently for P of 4, print from 1 to 4 to complete. That's finished now, and so it's ready to move on to its final line before it itself returns. It'll print its 5. Return, Everything without loops. All right, so that's why the code is working. Are there any questions now that you've seen that about why this code is doing its job? Another fun thing to do is, like, if you can't be bothered to draw these yourself, use that C++ tutor website. It will do this for you. Okay? Highly, highly encourage it. All right, so here's this code. Boop. I have a question for you now. Please see if you can work together. I'll put it right here, let's say. I would like you to come up with a recursive answer to print from 1 to n, not in order like we just did, but in reverse. All right? That's my question for you. Let's see here. And why not? I'll give you a few minutes to try this. We can go to the written ice page. And please do attendance. I'll stop that after we finish this question, if I can remember. I'll clear it out. You can elect a leader if you'd like. You guys can work yourselves. I don't mind. But help each other for sure. Talk to each other. Say hi. And then here's your question, right? Figure out a recursive solution. Like, make your own function. Print from 1 to n. Print from 1 to reverse or whatever. I don't know. Reverse print from 1 to. Call it whatever you want, but it's going to be a recursive algorithm. It's going to print from 1 to n in reverse order. All right, so think about, like, draw out some examples. Find the recursive case. What does P of 5 look like? What does it mean to print from 1 to 5 in reverse order? What will appear on the screen? Where is the smaller call? In what order does it have to happen? How do you build up the final answer? So use this. It'll look a lot like this, and see if you can come up with it. All right, I'll give you like 4 minutes to try it, and then I'll show you my way. What's different now? We still have to find the recursive case. Does the base case change? I always recommend doing an example, like, call it with 5, what should happen? Circle the smaller call. That's what you get for free, thanks to the magic of recursion. And do yell at me if you have questions. So where will you call yourself, and what will you give? What's the smaller answer? How will you use that to build up the bigger answer? All right, another few seconds and I'll show you my way. Let's see if we could figure it out. Anybody brave enough to press submit? Nice, nice. Yeah. All right, let's see what we're thinking. Did we get the right order? Did we find it? Did we like practice? Did you see it working? Woohoo! Ooh, yeah, it's looking good. Very nice. I see that our order is gonna do the right thing, I think. Or so I think. Nice. We noticed that, yeah, something's got to change from what we just did. Like, it's going to be an order that changes, isn't it? Very good. So, yeah, thank you all for that. Good thoughts. And let's draw it out now. So what does P of 5 look like? Let me draw that for us. Where was I? I was right here. So, all right, I want to print from 1 to 5 in reverse order. So on the screen, I want this, right? It's a very wobbly screen. Sorry. 5. I want 5, 4, 3, 2, 1, don't I? And where's my smaller call now? So I want to print from 1 to something, a smaller version of 1 to something in reverse order. Do you see that it is now not the first thing in the output, it's now the second thing in the output. So there's a key difference between this picture, right? Smaller thing's the first thing, versus this picture, smaller thing's the second thing I must do. Do we see that? All right, and that's going to influence everything, actually. So like here, this is our call to P of 5. Let me save that for later. Oops. Copy and paste that onto the next slide. Let's talk about it. So hopefully you didn't look ahead on the slides from last time. But here is, like, this is P of 5, right? And so in general, in your recursive case, you got to print your n, right? That's the bigger original number. Print your 5. And then recursively, print the smaller thing. Print from n minus 1 to 1 recursively. That'll still work, because that's your P of 4, okay? But the order now is different, isn't it? P of 4. Sitting right there. And then you can imagine, you can like draw more pictures, like what's going to happen when it breaks down, print from 1 to 0 in reverse order. You can think of it that way, but honestly, you can keep the same base case. Like the number is so small, it doesn't matter anymore. Just do nothing again, okay? So honestly, the only difference in the implementation is the order in which you make the call, because you're still doing these two things. You're making a smaller call to calling it with n minus 1, and printing your number, your n. You do that first versus second. That makes all the difference. So if I messed this original one up, if I messed it up and I did it this way, I would have gotten reverse order. Does that make sense to us? Because the name doesn't matter. The order of these things happen, that these things happen in, matters. All right? So, all right. Let's separate this with a new line. What do I want to call this? Let me call this print. We'll call it reverse print from 1 to 2. Okay? So it's going to look pretty much exactly like this. It's the new name. Reverse print from 1 to 2. Boop. So I got to call it with that name. And then all that's changed is the order of those two calls. The recursive case call, and then like printing your own n value. Okay, that's all that matters. And like we read it off though, like the answer, it was telling us that, right? Print R5, then do the smaller thing. That's got to be the order, but that's going to make all the difference, right? That's the only thing besides the name. That's the difference between these two examples. There's my 5, 4, 3, 2, 1. All right, it's exactly the same code pretty much. I've just swapped the order of these two lines, and suddenly it's in reverse. All right, but we understand why it's in reverse because we just read off the answer from the drawing. But that's really neat, isn't it? Just doing it, swapping that. Like, all right, we noticed we needed it, but that gives us reverse order rather than normal order. Crazy. Any questions about that? I think it's fun. And it's just a good one to study, I think. Good one to practice with. So, yeah, consider for an extra exercise, try to draw the stack diagram of that one running and watch it work. Or use the C++ tutor website on this entire example. I think that would be fun too. All right. So, yeah, if we're good with those, just some printing examples, let's do something slightly harder now. All right, let's print the characters of a string in order. All right. So let's figure this out. Base case and recursive case. So I've got a string, not just a bunch of numbers, a sequence of numbers. I got like a string. I got characters in that string, of course. And I like to print all the characters of that string, let's say in order, for some reason. I want that. All right, so here they are. All right, can anybody find for me in this string, is my full string that I want to print all the characters out of, that's my problem. Does anybody see a smaller string, right, to print out all the characters of? Because that's a smaller problem, isn't it? Smaller version of the same problem. Yeah, does everybody see that? Like here's a smaller string I could send off. That's one way to break it down. Like so you could break it down into like the smaller string this way and like the first character that you have to worry about. You could also do blah, BLA, right? It's not BLA, like that's a smaller string too, and break it down into the last character and everything but the last character. Those are two like valid ways. They're both correct to break down the string that way. And so as long as you have a smaller string, whichever way you decide, it's going to work. Okay, that's the moral of this story. So let's break it down in that way, and let's talk about the recursive case first. So what do we want to do? I want to print out, right? If I want to print the characters of the string in order, I want to print the first character because the B needs to appear first, and that's not part of the smaller string. So I got to do the first character and then print the smaller string, everything but the first character, this guy, recursively. Right? That's it. That's my recursive case. Does that kind of make sense? And like this is what I want to see on my output, of course. If we break it down that way, this is the order of it all. Like I always want to see BLAH, but this is now going to be the recursive part, printing this much. Okay, that's the way we're going to break it down. So that's the recursive case. The base case, if you think about it, like has to do with the problem this time. Like when do we have we know immediately I don't have to do anything usually. Like when am I done? And I know the answer immediately to printing all the characters of a string in order. I don't even have to look in the string. Well, that's when the string's empty, right? If you have an empty string, then you need to print all the characters of that. Well, you're done. Like you're done before you started, aren't you? So that's your base case. Empty string, do nothing again. Okay. But again, there's multiple correct ways to do this. You could make a base case as like a size 1 string if you wanted to. You could have the different kind of recursive case where you split it up this way and that way. Either one works. Then you draw it like that, right? Does not matter as long as you're consistent. All right. And so yeah, let's talk about this. So how do you break it down into the first string, the first character, and the rest of the string? Well, this is S at 0, right? That's the first character. That's easy to get out. To get the rest of the string, it's a substir process. You do like s dot substir, and then you give a starting index, and then like the last index, size -1 or something. You give how many characters you want to take. So like I want to take 3 or something. But actually, if you don't give that, there's a default parameter. Well, that's a fun sound. If you don't give it, like if you just give the starting index, it'll take until the end of the string. All right. So that's the magic starting index. The other one's a default parameter, just like gets till the end. It works out. So yeah, that's how we can split it up. This will give us the smaller string that we can call with. Okay, that'll be the goal. So let's code that. Where do I want to put that? I'll make a new file, definitely. Print chars.cpp. So all right, I'm going to work with strings. And so here's my string. String s equals blah, and let's call print chars. That'll be the name of it on s. All right. So here's my function, void print chars. It'll be recursive. It takes a string, and we're not going to mess with the string. So let's take it as a constant reference. Be good about it. Okay. So now let's implement. I'm either in the base case or the recursive case. I have to figure out which. Right. That's always the game. So if the string is empty, then I want to print all the characters of an empty string. That's my base case. Base case, there are no characters to print. Do nothing. Empty body of that if. Bless you. Otherwise, else. This is my recursive case. And just like, due to the way we're breaking down the string, just like we were doing for the print in order kind of thing, I want to print my first character, my B. I got to worry about that. So cout s at 0. That's the first character. So that's the first thing we do, print the first character. And then I need to print the smaller thing, the rest of the string now. Recursively print, I spelled that wrong, recursively print the smaller string. So All right, I need to print the LAH, the rest of the string right now. That's a smaller string, so I can ask myself, it will work. You just get to assume it works. All right, so print chars of the smaller string. How do I compute the smaller string? It's this. All right, make a subster starting at index 1, going until the end. All right, and so that'll create a new string, so it's fine. I'm not changing the original one still. And then, yeah, it'll make its way down the base case, build it back up, and do what it needs to do. All right, so that should work, and I'm calling it with blah down there. Let's see if it works the first time. Whee! Oh, I forgot a new line. Oops. Just print them all on the same line right now. But it worked. Let's do an MDL here. Yay, there they go. All right. That is pretty much equivalent to the print the sequence of numbers example. It's just now we're making a smaller string. Still a smaller thing, still a recursive call, still will work. All right. Are there any questions about this problem? Does that make enough sense still? As long as you find something smaller, you get to just assume that that thing works for that smaller call.
What did you set the value inside of subster?
1 is subster 1, so take starting at index 1, and then there's usually a second argument too, but by default it just takes until the end of the string, and that's what we want here. So that'll get the LAH out, which is exactly what I want to call it with. Okay? Yeah. Other questions? That's the goal, that's the idea, and you better believe we can do the same thing in reverse, and it's just going to be me flipping those two lines, isn't it? All right, so let's draw pictures to notice that, but that's going to be the same idea. And it's just going to fall out of the picture. So here's my string again, LAH. Again, I'm going to break down the string. Like I want to print all the things in reverse order, right? So it's going to be hold, I guess. And this is the way I want to break down my string. I've decided I'll break it down into the first character and the rest of the string because we know how to do that now. Easiest. And then, all right, that means if this is my smaller string and I want to print all the characters of a string in reverse order, there's my smaller string. I can make a call, assume it's going to print all the characters of that smaller string in reverse order correctly. I just get for free, right, this. It's going to do that for me, to assume that it's going to work for me. And then my job is to worry about the character that has not yet been printed, right? And so, do you see the order difference? Print your first character. If you're doing it in order, print your first character, do the rest recursively. If you're doing it in reverse, make the recursive call first. Print the rest, or reverse first, and then worry about printing your first character. Okay, that's all you've done. I've swapped the two bullets in the recursive case, and that gives you reverse. All right, base case is exactly the same. Print all the characters in reverse of an empty string. Still nothing to do, right? Interesting, right? So let's watch that work. Boop. So let's call this print chars reverse. And let me separate these with a new line. Print chars reverse on S. And legitimately, the only difference is print the first, recursively print the smaller string in reverse happens first. Like this is its name now, print chars reverse. Okay, so I'm calling myself now, just gotta be consistent. And then yeah, print your first character at the end of that, and that will give you reverse printing. So I'm calling it with blah again. And you see, in addition to the first one, there's my hulb right there. Beautiful, beautiful and reversed. Any questions about that? Yeah.
So does it print HAL and then
Yeah, so try to draw a stack diagram is what I recommend, but you get to assume that the recursive call, the smaller call on the original call to the function, this one right here, in a chunk, it's going to print HAL. That's what you get to assume.
So it's not going to go find a smaller string in HAL.
It will make its own recursive calls, but you don't have to think about that as the implementer. Due to the magic of recursion, you just get to like, all right, that's a smaller thing. I get to assume that's going to work. As long as you build up the right answer, it will make its way down to the base case one character at a time and it will work out. So yeah, try, once I give you this code, maybe take it to the C++ tutor website. It will draw the stack for you, or try it yourself for extra hard work. But yeah, that's a good question. It'll keep on calling on HAL. It'll call it, then that one will call it like that with HA and L, and that one will call it like that. Eventually, it will make its way down to the base case. It'll chop a character off each time, so the stack will grow. But that's something I want you to discover. All right, but they'll look exactly the same as these kinds of things we were talking about before. Good. Any other questions? So yeah, order matters. Just like follow the diagram. You're going to circle the call. That's the right order. Mess up, right? If you mess up and you accidentally did it in this order, you suddenly get like normal order rather than reverse order. Okay. Which is kind of cool to think about. All right. If we're good, we've seen a lot of examples. I'd like you guys to think in pseudocode this time. So please, if you're already on the written nice page, I won't clear it. You can just like re-edit your post and click submit again. That's fine. One way or another, write an answer in here. So work together. And here's my question for you. Right? I'd like you to don't go to code because this is hard in code, but as an English idea, it's fine. I'd like you to come up with a recursive algorithm to capitalize a string. Every character in a string. That's my problem P now, right? Capitalizing a string. Only think in English, think in pseudocode, because this is harder than you think in real C++. I'll talk about why. But try to draw, like maybe I'll even give that to you, I don't know. So here's your string, right? In some way, you were given this string, right? BALAH. What you need to do, right, is convert it to all caps, blah, somehow. Okay? That's your goal. Think about what's going to happen. Like, how would you break it down again? You can do the same kind of breaking down that we talked about. So in English, like these bullet points that I've been giving you, see if you can come up with the algorithm. How would you capitalize this string? Okay? My hint is that the order is not really going to matter because you just want an effect to take place on the actual string, right? It doesn't matter if you capitalize this one first or that one first. As long as it's done by the end, it doesn't matter. But that might influence how you do it, all right? So does the question make sense? So in English, in pseudocode, in the bullets like I've been doing, try to come up with an algorithm to capitalize a string. Change all of its characters to capital letters. Okay? Try to complete my drawing. Where's the smaller problem? How will you use its answer to build up the original, bigger problems? Capitalization. I'll give you another 4 minutes. We can break down the string the same way we've been breaking down the strings. What's the recursive case? What's the base case? Get a little weird. In English, it's still. What's that? Recursive function. Everything we're doing in recursion is function based. Function that calls itself. Another minute or so to think about it. It's an interesting idea. It really is. Yeah. All right, another few seconds, 15 seconds or so. If you're feeling brave, enter in that answer. Just pseudocode then. All right. Let's take a look. Yeah, let's see if anybody got it. I think I didn't want to refresh it just in case you're on the same page. I don't want to delete things because weird things might happen. But yeah, looks like some of us changed it. Nice, nice. Yeah, I like what I'm reading. Dun, dun, dun. Call down here. Here's a thing. Last example. Void print function. Nice, somebody tried. I like that. I like that a lot. Let's see here. You, whoever you are, that's not nice. Let's see here. Alright. Change each index. Smaller recursive call is going to do it for the smaller string. I think we're getting it. I think we're getting it. Nice. So, thank you. Thank you for your thoughts. Except that one person. And then, let's draw it. Alright. What's the recursive case? How are we breaking this down? Again, we can break down in the first character and the rest of the string. So what's going to happen, right, in the recursive case? What needs to go down? Recursive case. Just everything needs to be capitalized by the end of the day. Recursive case. All right. And if you think about it, like you need to make this recursive call. What's it going to do? It's going to capitalize the LAH on the smaller string, right? You just get to assume it's going to do this. LAH. So like that'll capitalize the smaller string. And when you make the recursive call, so you need to do that for sure. And then your B is what's left over, the first character. You need to worry about capitalizing that too, all right? And actually, though, the order doesn't matter. In some order, do those two things, right? Because you just care about the final effect, don't you? In some order. What I need to do is capitalize the first character, eventually. Could be the last thing I do, doesn't matter. Because I'm not printing it. Capitalize the first character, and then capitalize the rest of the string. The rest of the string recursively. Okay? Do you see how it doesn't matter? Like you could do like capitalize the B first, then the LAH, or capitalize the LAH first, then the B. The order of these two could be swapped because you just care about the final effect. Does that make sense? That's kind of the trick there. And if you think hard about how you'd implement this, you can't do it with a C++ string, because like substr gives you a new string back. You couldn't even make the smaller string if you tried. Okay? What's that? Oh, okay. Yeah, you can't do it with a normal C++ string unless you do some weird memory hacks, and that's not correct anyway. So, yeah. The secret with C++ is you need to like pass along which index you're working on. You need to keep the same original string always and keep on passing. You need a second parameter that changes. All right, that's how you can talk about the smaller string. All right, that's the secret there. But you can do it in this exact way with a C string. All right, so let me show you that. This is going to look very, very weird. All right, so a C string, you can do exactly what we just talked about. All right, you don't need an extra parameter or anything. Like if this is your string S as a C string, here's what you can do. All right, whee. So it's not just blah as a C string, is it? It's blah with that null terminator at the end there. Okay, so that's the first new thing. And we can still break it down into the first character and the rest of the string. All right. And then there's going to be a way to pass it. All right, so the goal is like take this and transform it using recursion to all caps BLH, right? BLH, and then null terminator. All right, so that's our goal. And here is how you would do the recursive case. Again, it's like, all right, let's just do it. Let's pick some order. Let's do the first one first, capitalize the first character, start of the string, and then recursively capitalize the smaller string, all right, after the first character. So we're gonna have to call this function with a smaller string, but it's still the same string, all right, in a sense. So these exact characters. Don't compute a new string, because I want to mess with that original string. All right, and here's the secret. Here's how you pass the smaller string as a C string. So first of all, remember that a C string kind of looks like this. You can't really do this in C++, but like pretend its type would be char star, right? Like S, S2 or whatever equals ABC. This is not perfectly correct C++, but like that's kind of the right type, right? And so what does S2 look like in memory now? If that's your string ABC, well, it's ABC null terminator at some address, right? We have to go to pointers to do recursion on C strings. So, all right, say that this A starts at address 100, then the B would be 101, C would be 102, null terminator would be 103, and so S2, if you just say S2's name, it's really a pointer to the start, isn't it? Because that's what a C string is. It's a char star. It's a pointer to the start. That's holding 100, essentially. It's pointing right there. And that's how you pass. You pass along in the char star. That's the start of the string in memory. All right? The secret is, like, how do you pass along this string, right, the smaller string? Well, you must pass the address of the B character, the first character that you want to be in the string. So you have to compute that based on S2, right? That's the secret. And so here, let's just underline it, right? A C string is represented as a pointer to its first character. So if I want the string starting here, that's S2, but S2 plus 1 will calculate address 101 for me and point right there. And I can pass that in my recursive call, all right? Disgusting, but it will work, and that's how you can do it with C strings. C++ strings takes a little bit extra work. So let's do capitalize.cpp. Cool. And let's do exactly that. So I can't do char star, whatever, s equals blah. And you have to declare it as a char array, actually. That's the correct way, but the type is still char star, so you know that, right? And so I'm going to make a capitalize function that takes S and messes with it and capitalizes it. And so by the time it's done, S has been all capped. All caps, I guess. So it's void capitalize, and it takes a C string, so char star. And now I'm messing with it, all right? So that's the recursive case. We just talked about the recursive case. Let's also talk about the base case, all right? So like, when are you done? Like, when do you not have anything to capitalize anymore? Like, what's a string I don't need to do anything for? It's already capitalized. It's the empty string. Just capitalize all letters in an empty string, you're done. So just like notice that the string was empty, and you can call it a day. So that can be our base case, right? So there's a couple different ways to notice that your string was the empty string. You'd be like, hey, if stir of 0, if the very first character was the null terminator, that means it's empty. That's one way to do it. You could also include the C string library, and be like, strlen on stir. Hey, is that 0? If it's 0, then I'm empty. You got options. So that means that's your base case. Right? Base case, do nothing. I don't need to capitalize anything. Does that make sense? Otherwise, else, I'm in my recursive case, and oh man, I better do this work. In some order, this order doesn't matter. Capitalize the start of the string, all right? Recursive case. Capitalize the start of the string, that's stir of 0, right? Stir of 0, you can use this char star like an array. It is, secretly. Stir of 0 equals its uppercase form, and all right, I need to call 2 upper, don't I? 2 upper on stir of 0. And that lives in the CC type library. Okay? So that's the secret. And yeah, then we need to just make the recursive call. So that's going to capitalize like the B or something. And then right after that, I need to do the LAH. So do recursively capitalize the smaller string. That's everything after that first character. Here's my call. I'm going to call capitalize, right? Hand it off to a smaller version of myself. Capitalize. What do I capitalize? Where's the smaller string? I need to pass along the address of where it begins. That is my current stir plus 1. There's my smaller string. And then passing it along that way. So that's correctly going to work. And that's how you give it the smaller string as a C string. Okay? And so yeah, this will do the work. And then print the string out. And it should be all caps blah by then. Cool, I can show you all the code at once. Awesome. Boop. Yay. All right. So yeah, it's an interesting way to do it, but it works. Are there any questions about that? So we needed pointer knowledge to make this recursive C string function. You good with that? Because I want to give us a very hard example next. I want to make sure we understand all the other ones. Are you ready? Are you really ready? Yeah. I'm excited for this example though. All right. So you might just be checking out by this point. I gave you so many examples like Fibonacci, let's print out all the numbers in order. This is dumb, right? You're probably thinking that. Like, okay, I could just use a for loop. Why do I need recursion? You might be thinking that right now, and I don't blame you. All right, this is CSCI 40. It's hard to give a good explanation as you're just learning how to code. Here is my good example. All right, I would like to make a function that gives back every way to jumble up the characters of a word. All right, that's what I want to do. That's my problem, and this can only be done recursively. There is no way to think about this. You would be hard-pressed to find a way that's iterative to solve this problem. Right? Here's what I'd like to do. I'd like to make a function called perms that takes a single string and gives back a vector of strings, all the different permutations of the characters of that string. Right? So if I call perms of ABC, what I'll get back, thanks to the magic of recursion eventually, will be a vector of all the different ways that you could have jumbled A, B, and C together. Right? All the different strings. So ABC is still an option, right? Or maybe the last 2 characters got flipped. Maybe it could be HCB, right? Another option is B could have come first. BAC, BCA, or C could have come first. CAB, CBA. There are 6 options. It's 3 factorial. So that is the function I'd like to write right now, all right? You cannot do this without recursion. Here is your good example. Here's why you need to learn this, okay? So well, let's think about this. We got to break it down into a base case and a recursive case. All right, let's figure this out together. So first of all, where is the smaller word scrambling problem? Do you kind of see it? I kind of hinted at it. Does anybody notice it? Can you find me a smaller string I need to scramble the words of? Well, kind of here's how I broke it down, right? A could come first, right? If you fixed A first, then now you have B and C to scramble. Does that make sense? Give me all the different scramblings of B and C and tack an A at the front. Does that make sense? There's your recursive call for every different option. All right, let's pretend that B comes first. Fix B at the front. Go and jumble recursively a smaller number of characters. You see that? That's where the recursion comes in. And then like fix C at the front. Go and jumble now a smaller number of characters. So you're going to get back like A, B, and BA as a vector of strings again. Okay. So that's going to tie into the recursive case. Well, let's talk about the base case first. So like when is there nothing to scramble? Like when is your job done? You don't have to do anything at all. That's when you're trying to permute all the characters of an empty string, right? There's no way to do it other than just give back the empty string, right? So if somebody asks you for all the different ways to jumble the characters of an empty string, you can just immediately give back, like, this is your return type, remember, vector string. Give back a vector just with that one empty string, right? So that's your base case. I hope that makes at least a little bit of sense, all right? Are we ready to talk about the recursive case in detail? All right, so what you do in the recursive case is you got to try every first character. Each one of these get a chance at being fixed as the first character, A, B, and C. Like A could be first in those two cases, B could be first in these two cases, C could be first in these two cases. And then you go off and you scramble everybody else. All right, so you pick a starting character and you're eventually going to try them all. Right, so let's say we're working on the A's right now. We're going to fix A. So we've chosen, choose A to come first. And then you go off and you scramble the rest of the characters but A, right? You're like, all right, I'm working on A right now. Let's think about everybody but A. Scramble those guys. It's a smaller scrambling problem, yeah? And so I'm going to go off and I'm going to scramble BC. That's a new string to give to my perms, and I'll get a smaller answer back. I get to assume that the scrambling of BC works. I get to assume, due to the magic of recursion, this will give me back a vector containing BC and CB. Those are exactly what I need right now. Because if I just tack an A at the front of each of those strings, I have two new candidates that are part of my scrambled vector of original strings. Like, take the A at front, add it to the front of both of those guys, and now I've computed two strings that are part of my final solution. I've got ABC now, and I've got ACB. Does that make sense? And then I do that for B and for C. That same problem. That's all going to become my final answer. All right? Recursively scramble the remaining characters, build up the final answer by adding your starting character that you've just chosen to every result string for the smaller scrambling problem, and make sure everybody gets a chance at being the front. Okay? Does that make enough sense before I go to code? You need recursion for this problem. You cannot do it without recursion. All right? So this is why you're learning it. All right. I'm definitely going to make a new file. I'll call it scramble.cpp. I'm going to need strings. I'm going to use vectors. And here is my problem. It's going to be called perms, right? This is my start of the function, right? There it is. I'll deal with it in a second. And yeah, let's be like, all right, I want to call perms on ABC. Or blah or whatever, and it'll give me back, right, a vector of all of its combinations, all the different permutations, vector string, I'll call it V, equals whatever that gives me back, and then I'll just go print them all out for every constant string reference, S in the vector V that eventually gets filled up, print out each option, each permutation, okay? So now, let's do it. Let's figure this out together. All right, okay. Base case or recursive case. It's the same problem always. Figure out which one you're in. Do it. So, all right, let's check if we're in the base case. Let's check if our string is empty. If so, we're done. So if the string that we're trying to scramble all the letters of is empty, there's no letters to scramble, base case. And so I need to return just a vector containing the empty string. That's my answer. That's all the ways to permute the letters of the empty string. There's only one way. Vector of strings result equals the vector containing just the empty string. There it is. And like return that. You can return the vector just fine. All right. Otherwise, else, I'm also going to have a vector string result that I'm going to add to. Start at empty though. This is going to be my recursive case. All right. So here, that's what I was going to start out as, and then now, all right, recursive case time. Are you ready? Ready to translate this into code? Let's make it happen. We got to try every starting character. So choose A first, then B, then C. So we're going to iterate through this string, every character of it. So there's going to be a loop. There's going to be a normal for loop inside of this recursive problem. That's fine. All right. So I want to try every character and scramble the remaining characters. So there's my smaller call. I'm going to tack the thing at the front and keep on trying the rest. All right. So I need to loop through every character of this initial string, the A, the B, the C. Give me every index of that. So for int I equals 0, I is less than the string size, I plus plus. Cool. That thing at S at I right now, that's my starting character. S at I is now my starting character. Like the first time it's the A, the second time it's the B, right? So that's my starting character. That's the one I'm fixing right now at the front. So let's choose that. Char starting char is S at 0. Or sorry, S at I, excuse me. And then I've got my first character. Now I need to get every other character. It's like, all right, maybe I'm looking at the B right now. I need to somehow make the string just A and C, right? Give me the smaller thing. Tack off the B, whatever I'm fixing at the front. Give me the other characters right now. Give me the remaining characters. So, string remaining characters. Let's calculate that. Let's start with the original string. And then what I'm going to do is I'm going to erase this character out of it. That's how I can get the smaller string. Okay. So I'll say remaining characters dot erase at index I one thing. So that will tack off whatever character I just used, and I'm going to fix it my start. If I just chose A, I'm going to erase the A and give me just BC. If I just chose the B, I'm going to erase the B and just that'll give me the AC string. Does that make sense? That's my smaller string. Then I'm going to scramble. All right. I get to throw that off to myself right now. All right. I get to assume that it works because it's a smaller call. All right. So what this just did is it removes the starting character. All right. And then, all right, I need to permute all of those smaller characters. Like if it was BC, go and scramble BC. Get that answer back for me now. All right. So I'm going to say perms on remaining characters. Calling myself. Give me the permutations of all the characters in the smaller string. All right. So I'll call this smaller string perms. And what is it? It's a vector of strings. This is something definitely to study. It's a good example. I'm getting back, that's the return type. I'm getting back a vector of all the different jumblings of this smaller string. I get to assume that's going to work for me. All right? Don't have to worry about how it works because it's going to melt your brain if you think about it too long. All right? So I just have that vector. I have my BC and my CB now. I have that. That's in smaller string terms. All right? And I have my starting char. That's my A. I just need to plug that at the start and add that to my result. All right? That's what I got to do right now. Okay, so let's iterate through this entire thing for every string in it. For every string, I'll take it by a constant reference, why not? For every smaller string perm, in smaller string perms, that's like my BC and my CB, that's what smaller string perm is right now, tack my starting char at the front. So compute the string starting char plus that particular thing, plus the BC, plus the CB. And that's part of my result, okay? Let me comment first before I fix that. Add starting char to the front and put it in the result vector. All right, that's what I'm doing. And so my result vector is called result. It's empty right now, or maybe it's been filled a little bit. I'm going to say result.pushback. This is a new answer. All right. Say that I'm looking at like the BC right now. I'm going to tack A at the front and make ABC. Add that to my answer. I'm looking at the CB. Tack the A at the front. Make ACB. Add that to my answer. Answer vector. That's what I'm doing each time. All right. So it's a nested loop, surprisingly, and it's still making a recursive call though. Like that's the hard part. It's figuring that out for us. Just the magic of recursion is jumbling the smaller string. We're just using that answer, and it will work as long as we build up our answer correctly. All right. And so by the time we've done this, we've tried every character. We've let B be at the front. We've calculated the B's, added them to my result vector. We've let C be at the front. We jumble A and B into all of its options. Tack the C at the front of those. Add those to my result vector. Then I filled it all up. Now result holds the final result. After this loop is completed, I can return result one more time, just like I did in the base case, and then I'm off to the races. All right? So that is a very long recursive case. Can't even show you the whole code right now, but that's it. That's what I'm going to do. And if I return that, it will work. And so again, I'm scrambling ABC, and it's going to print out all the scramblings once it returns. This is not an easy problem. There they all are. A's at the front, B's at the front, C's at the front, and this works no matter what. If I said A, B, C, D, well, it's just going to do the same thing. Now, there's going to be 24 options total. And like, all right, A could have been at the front. Here are all the 6 options, right? Because then I got to go scramble B, C, D. Here are all their 6 scramblings, right? Tack A at the front of those. Let B be at the front. You got 6 options there now. CB at the front, DB at the front. Doesn't matter. It'll always work. The recursive call will get to the right answer. You get to assume it's going to do the right thing. I would not dream of drawing the stack for you right now, but that's just the magic of it. All right, it's going to work. You get to assume that this call right here scrambles the remaining characters correctly, as long as you build up the answer correctly. All right, and there is no way to do this without recursion, guaranteed. All right. I guess I don't want to eat my words. Like, you could do it if you learned about the stack data structure. There's a way to do it, but you're emulating recursion at that point. So morally, recursion is the only way to do this. All right. So this is a fun example to study and stare at for a while until you can do it too. But I think that's all that I wanted to say about it. It works. It works, and it's a cool, cool thing that you might want to do one day. Are there any questions about it? Yeah.
Okay, so how come the remaining characters is only like erased by
Oh, that's because I'm trying to calculate this part. These things. Like, I want to scramble these smaller strings. Like, I start with ABC, the original thing, then I tack off the one that I'm shoving at the front. So that's just going to make AC. That's what I'm erasing, that one character that I've already chosen to be at the front. Any other questions? Yeah, this is one to study for sure. It's my good example of the day. This is why you should learn recursion. All right, the last thing I want to show you, surely your book's going to talk about this, but if not, the internet can talk about it too. I just want to give you a classic example of recursion. I'm not going to implement it. There are plenty of fun YouTube videos and animations on the internet about this. It's just a classic example that, like, they'd take my computer science card away if I didn't tell you about it. So go learn more about it if you'd like. You don't have to understand it, just like this last problem. It's just like, you cannot do this without recursion again, all right? This is like the standard example that people give, but I like this one better. So, all right. It's called the Tower of Hanoi. It's a game. Has anybody played it in real life? It's just like you're stacking some pegs, and the pegs are of different sizes. Yeah, you're stacking discs, on 3 different pegs, and the discs are of different sizes, and the rules of the game are that you can't put bigger discs on top of smaller discs. So you can't, like, take the smaller one, put it right there, and take the next smaller one and put it on top. Like, that's invalid. Not a correct way to play the game. You can only put that next smaller one over here now. And then you can put this one on top of it now. Like, you can only stack like that. Okay? That's the name of the game. And using those rules only, get this entire stack over here. Okay? It's a hard problem. So it's a fun little game. And the way that you can solve it, you can extract, like, a recipe to solve the program, to solve this game for a given size of a stack using recursion. All right? So here's just like a high-level way of doing it. Look into it. It's probably in your book. It's definitely on the internet, everywhere, if you want to learn more. So the base case of the recursion is you're playing a Tower of Hanoi game, and there's just one thing. If there's just one thing, it can go anywhere, right? So that's your base case. If you want to move the smallest disk, for example, that's your base case. You want to move this guy, guaranteed either the peg's empty or somebody's bigger beneath it. You're good. So that's your base case. All right. And then the recursive case is, all right, here's what you do. Okay. There's a concept of, here is your source peg. Here is your destination. You want to get them all over to here, destination. And, like, here's your intermediate peg. You can use this for your scratch work. All right. And so here is the recursion. It's like, do you see that everything but the last disk, keep that one down there, everything but the last disk is a smaller Tower of Hanoi problem? That's the secret. So, all right, what you're going to do is recursively move all these guys to the intermediate peg using destination as, like, the intermediate in that case. Like, get all those guys right there. That's your smaller call. And then all these guys have been moved to right here. This peg is empty again. Take this largest peg, shove it right here. Yeah. And now this peg is empty, all right? And so now the name of the game is move all these guys to this peg, all right? Take all these, move them right here, right? Move them right there, recursively, so that they stack finally. That's it, all right? And then use this one as the intermediate in that case, because it's empty now, all right? So that's what these words are saying, all right? Move the biggest disk to the destination, then recursively move the smaller stack from here to here, using this as the intermediate this time. And you can write a recursive function that tells you move the top thing of peg this to peg that, and, like, it will print out for you the way to win this. Okay, and so yeah, recursion to the rescue again. It's another good example of, like, why you need recursion. You can't do that with a loop. Okay, It's just a smaller problem on top of smaller problems. All right, so yeah, look into that if you're interested. That's as much as I want to say about it, though. Okay. Any last questions about any of this? Let's see. All right. So yeah, fun examples for the day. It's just like powerful ideas. I really like recursion. All right. So yeah, the last thing that I want to do is give you your next lab. It'll be due after the midterm, but you might as well know about it now. This one's about files. So it's a nice, easy lab, okay? In theory. So let's see here. Which one was 8? So here are all the files you get. So in addition to other things, you get the complete works of Shakespeare again. And so, yeah, here are all the files. And so the first thing I want you to do is make a word counting program. You're gonna get command line arguments for this program. It's called count words, and you're gonna give it the name of the file first. That's argv of 1, right? And then you're gonna give it the name of the word that you want to count inside of the file. All right? That's what you want. That's the one you want to search for. And apparently, inside of Shakespeare, he says thou that many times. All right, so that's the answer that I want for you for that word. And like thee appears that many times. I do want you to worry about capitalization because maybe thou appeared at like the start of a sentence and it was capital T. So I want you to account for that. Look for all the different capitalizations of that word. Okay, so that's what I want you to do. Okay, so you're going to use command line arguments. Then this is going to be countwords.cpp. So you're going to use command line arguments, and then you're going to get the name of the file, right, in argv of 1, open it. You're going to get the string you want to look for, like thou, in argv of 2, get it, and then like you're going to keep a count, and then you implement, okay? So an easy way to search for any kind of capitalization, like thou at the start of the sentence, thou with a comma at the end of it or something, like it could appear in any different way, right? I've given this to you. I want you to implement this fixed string function. It takes a string by reference and messes with it. Because say you're counting the word the or something, all right? What you should do is like, because as you read a word, you're getting everything connected to it. So like maybe the appeared at the end of the sentence. Probably not, but it might, right? Depending on the word. It's like maybe the string was the period or exclamation point the or all caps the or like just at the start of the sentence the, right? All of those should count as the, shouldn't they? Even 0 though. So what you should do is you should fix up the string by going through it, right? If you got this one, for example, get rid of anything that was non-alphabetic, first of all, and then also convert it all to lowercase. See how that'll give you the for all of those? And like that's how you can count it properly. Does that make sense? So implement that and then it'll help you. All right, so call fixed string. Also on the thing that the user gives you, because maybe the user wants to search for that, just search for normal v, right? That works. So fix the string in both places. And then, yeah, just like read all the strings in the file, fix them up, check if they're equal to what you're searching for after having also fixed up that particular string as well, right? So thou, thee, and thine apparently appear that many times in Shakespeare, and you can confirm that, right? So I've also given you some shorter files that you can use to count stuff in. So feel free to make your own as well. Like here's the quick brown fox, the sentence with all the letters of the alphabet in it. And so you can search for stuff there too. Consider also checking an empty file. That's like an edge case. But yeah, command line arguments. That's how you're going to run the program. And this is what it should do. Any questions about that one? Just read a file, ifstream. Read all the words of a file. So I've told you how to do that already. All right, so that's that one. There's one other thing. I've made you a cute little library. So this one, I just want you to use the library. It's called Etch-a-Sketch Library. This was a part of my childhood. Did you guys still have these? Do these still exist? You turn the little things. You can, if you turn them in the right way, you can make curves as well. It's usually just straight lines, one for up and down, one for left and right. Etch-a-Sketches, they're fun. You shake it when you're done. But I've made an Etch-a-Sketch library for you guys. And the way it works, you don't have to implement it. I've already implemented it. You don't even need to look at the CPP file for that reason. If you want to, you can. But you're just going to use the library. Finally, here's a library. You know its implementation. I'm just asking you to use it for once rather than make it yourself. So somebody else gives you this. This is like how it's going to work in real life. So here's a class called Etch-a-Sketch. And like, here's the public things that you can do if you make an Etch-a-Sketch object. You give it the kind of character you want to make marks with, so let's draw with a star by default, for example. And then you can turn the virtual knobs of this virtual Etch-a-Sketch. You can tell it to go left, and it will draw to the left. You can tell it to go right, it will draw to the right. Tell it to go up, tell it to go down. And it's secretly keeping track of a bunch of things, but you don't need to care about that because you're just going to use the library. You don't need to look. You don't need to look at the implementation if you don't want to. All right. And then yeah, you're just going to use the public stuff. And the final thing is you're going to say get artwork, and that's going to give you back a string of the pretty picture you built up. All right, by calling left, right, up, and down. Okay. So yeah, that's my virtual Etch-a-Sketch, and you can tell it what to do. All right. So let's see here. I've given you some files then. All right, I've given you some files. So your job is to implement readanddraw.cpp that uses the Etch-a-Sketch library. All right, so what you're going to do is I've given you 3 files. You can make your own, but do you see how they have like L's, U's, R's, and D's? Those stand for left, right, down, and up. Okay. Some of them, like one of them at least, did I mess with it here or not? Oh, sorry, give me 1 second. That's what I thought. Dun, dun, dun. It was working. It was working real hard. There it goes. Let's go back to Vim. Vim input 0.txt. This is what you're given now. These are the correct versions of the file. Some of them are not actual commands. All right? Some of those characters are not real commands, and you should ignore them. Continue to the normal ones. U means up, D means down, R means left. Okay? So exclude all the ones that aren't part of a command. All right? So you're going to get some of those, so worry about them. All right? And that's the secret. All right? So yeah, those are the files. You should have your program read and draw read. All right? Read the file and tell it to go left, right, up, or down if you see those characters. So you're going to read every character in the file. All right? Any other character is invalid, and you should skip it. It's not part of the drawing. All right? So you're just using the library. So again, you're getting the file name in argv of argv1. You're going to run it like this. So you say read and draw input1.txt, and you're going to make an Etch-a-Sketch object after opening the file. You're going to read every character, move the Etch-a-Sketch by calling the appropriate methods. Left, right, up, and down, right? And then just print the thing, the pretty drawing that you've built up inside of the Etch-a-Sketch. I'm just asking you to read a file and use this library that I've made, all right? So for example, apparently input1.txt, I worked very hard on these, by the way. This one just says hi, all right? So it's commanding the Etch-a-Sketch in this way. Apparently these characters in this way will make hi. Input 0, I think, is just a box, and input 2 is like a house. I try to draw a house. So look into that. It'll be fun. All right, but that's pretty much it. All right, so you're using the library, though, so you got to compile with the library. Just remember that. So yeah, you're just reading a file like input1.txt from a command line argument, right? You're commanding that library object. Okay, printing out the pretty thing that it's drawing for you. Yeah, I think that's all that I wanted to say. Any questions about that or the other part? All right, and that's it. So you got 2 weeks, plenty of time to do those 2 things. So you're submitting these 2 files. Those are the ones you're allowed to change, and that's that. So remember not to change the library because I'm testing you with the default version. Okay, but yeah, that's all I've got. The rest of the time is all yours to work.